There's a lot of stuff to cover in this video, including 5 new ports of Pesky Robots, an upgrade to my arcade cabinet, and showing off the next generation Commander X16, so buckle up. So we'll briefly start off by looking at the new platforms for Pesky Robots. The list is up to 25 now, which even I find hard to believe at this point. So the new platforms added since the last video update are the MSX, Nintendo 3DS, Picomite, TI-84 Plus, and the TIC-80. The first version I'll show is the MSX version. Visually, it looks pretty close to the other 16-bit conversions of the game, but this version won't run on a stock MSX system. It requires the V9990 video chip and the OPL3 sound chip to work. No MSX machine to my knowledge was built with those, but it is possible to put them into a cartridge, so I'm not sure how many people can actually run this, but here it is. Okay, next we'll have a look at the Nintendo 3DS version. Now, unfortunately, it does require installing CFW, or in layman's terms, jailbreaking your 3DS, but once that's done, you can easily copy this to an SD card and play it from there. As you can see, the bottom screen is used for the map, and the game plays very nicely on the system. The next conversion I want to show you is the Picomite, which is running BASIC, and I think this may be the only version of the game to actually be programmed in BASIC. Of course, it's running at like 133 megahertz, so that helps. The next version I want to show off is for the TI-84 Plus CE graphing calculator. Now, unfortunately, the calculator doesn't have any sort of internal sound, so the game is essentially silent, but it does support a USB to MIDI adapter, so you can have the MIDI soundtrack. And the last new port I want to show off is for the TIC-80 tiny computer, which is not a real computer at all, rather a fantasy 8-bit style computer. The resolution on this system is almost what I'd call Game Boy sized, but they were able to pull off a great conversion. Even all the musical soundtracks were converted by hand, so be sure to check out this one.
So all the ports I've just shown were done by other people as a hobbyist project. All I did was just a little bit of beta testing. As such, all of those versions are available for free.
It's hard to believe that it was 3 years ago when I made the custom Pesky Robots arcade cabinet and placed it at the Electric Starship arcade. And just as a refresher, it used an Amiga 500 as the main board, and this machine was moved to the Time Rift arcade since we first opened back in October. And in this video, I'm going to be doing a major upgrade to it. 3 years ago when we made the arcade cabinet, the Amiga version was the best looking and sounding version of the game. And it only made sense to use an Amiga in the cabinet as the platform for the game, especially since it would work with a standard arcade monitor. I did have an X16 version of the game, but at that time, it looked like this, which wasn't bad, but wasn't as good as the Amiga version. However, over the last 3 years, I've continued to improve the Commander X16 version of the game, a little here and a little there, and after a complete rewrite to the graphics engine, now it looks like this. In fact, now the X16 version has surpassed the Amiga version in a number of ways.
And so for the better part of a year, I've been wanting to upgrade the arcade cabinet from an Amiga to an X16, but the upgrade isn't quite so straightforward. There are a lot of challenges I had to overcome in order to make this happen.
The first and most important challenge was to convert the game from a disc-based game to a ROM cartridge. And then I needed to create some kind of high-score save system, add some sort of self-playing attract mode, add timeout delays in case somebody walks away in the middle of a game, and create some sort of interface for the arcade controls to connect it to the Super Nintendo controller port, and lastly, build some sort of interface from the VGA port to an arcade monitor. And so I'll take you through all of these and explain why I made certain choices.
Now, I wanted to have the game run from a ROM cartridge like this. Now, yeah, I could have put it on an SD card and just put like an auto boot file in there and have it run from that, but I really wanted it to be able to run from ROM like a real arcade machine.
But how do you go about converting a game that's designed to load in all of these files from disk to a game that runs in ROM? Well, the easiest way I found to handle it was just to combine all of the files into a single binary image and then just make a note of where each file begins and ends. And then I create a table that's like a rudimentary file system. Then I had a load subroutine in the game that was designed to load files from disk. And I just modified that routine to instead load files by copying them from ROM to RAM. So the rest of the code works pretty much the same. Now, one great benefit of having it boot from ROM cartridge is that it only takes about 2 seconds for the game to start, whereas the Amiga version took several minutes because it was loading from an emulated floppy disk. Another advantage I have is the Amiga version had to fit on an 800K floppy disk with the way that we had it set up. But an X16 ROM cartridge can hold up to 3.5 megabytes, so I can fit more stuff, which is good because it allowed me to fit some new things. For example, while the graphics are generally the same as the Amiga, the animations are somewhat improved. So on the disc-based version of the game, you can see how the air conditioner fans animate. There's only 2 frames. Depending on how you look at them, they can appear to move clockwise or counterclockwise. But the new cartridge version has 4 frames of animation, which were taken from the Sega Genesis version of the game. So the animation looks a lot nicer. Another addition is the high score screen. I say score, it's not really a score. It's based on fastest completion time for each level. And when the game is over, if your completion time is longer than the record holder, it will just show you the previous record at the bottom. But if you manage a new record, then you can enter your name like this so that it will appear on the scoreboard. And the interesting thing is, I can't even show this in the emulator, and the reason why is that the scores are actually stored here in this little I2C based flash chip on the cartridge itself, and that's something the emulator doesn't yet support. The other thing I added, of course, was the self-play attract mode so that the game will play itself. Now this is handy for a couple of reasons. Preventing screen burn-in is one good reason, but also it gives people an idea of how the game is played when they walk by the game in the arcade. Now one big problem this game has for being in an arcade environment is that the learning curve is a bit too steep and there's no user manual laying around for people to read, so if they at least watch the self-play, it will sort of give them an idea of what to do. Now, adding the self-play wasn't all that hard. The game already had 3 types of controllers supported: the standard keyboard controls, custom keyboard controls that the user can define, and then of course the SNES controller. So all I did was added a 4th controller type called self-play, and then there's essentially tables that contain a timestamp and a command to execute at each timestamp, and it reports back to the game just like any other controller. The timeout delay was also very important. In an arcade, people will walk away from nearly any game in the middle of gameplay, so it's important that after some time of inactivity, the game will reset back to the menu. This required extensive modifications since there were dozens of various input loop cycles that the player could be in waiting for input. Now, for example, if the user opens the map and walks away, or initiates a search and then walks away. So I had to find every user input routine and modify it with the time delay. And then we have the issue of the controls themselves. How do you connect arcade controls to the X16? I figured the best way would be through the SNES port. Now this had an advantage that most of the code was already in place to support that, but I could have used the I/O pins on the user port or a dozen other methods with some extra hardware. Since the SNES controller essentially has 2 8-bit shift registers inside, I decided to create my own custom board. I bought a couple of shift registers from Mouser and got to work. Since this is just a one-off board, I decided to just build it by hand rather than trying to get a custom PCB run for it. I'm going to use these terminal blocks to attach all of the buttons and joystick. I did a mock-up on the computer to see how I wanted to arrange everything on the board, so I put my 2 shift registers here, terminal blocks here, the left side is for the controls, and the right side goes to the SNES port on the X16. And all these are pull-up resistors. I based the design on this diagram I found online, which is pretty simple. I labeled all the terminals with a Sharpie, and it took probably 2 hours, but here are all the wires soldered into place. And I'll need a way to connect this to the SNES port, so I just bought a SNES extension cable on Amazon and chopped off the end I didn't need. And as you can see, I just poked the wires in here like so, and then tightened them down. And now I need to test it, so I'll plug it into my X16. I wrote a custom test program because unlike a SNES controller that only uses 12 of the 16 total bits, I'm going to be using all 16 bits. And as you can see, I labeled the extra 4 bits as aux0 through aux3. The X16 technically supports 5 game controllers, and number 0 is actually a virtual controller that the kernel simulates using the keyboard. You can see that working here. And then I've attached the ground wire to the G terminal block, which was just a very lucky coincidence that G comes after F. So I can essentially test these buttons one at a time by tapping the wire to the tops of the terminal block. And as you can see, the screen lighting up for each one, so I think it's going to work. And for the last challenge to solve, I need to find a way to convert the VGA port over to the arcade monitor. Now keep in mind that the X16 is capable of running at 15 kHz RGB, but it still uses the VGA port for this, even though in that mode it's not actually a VGA signal. So all I need to do is adapt the connector, not the signal itself. Now, rather than building a custom cable, I decided to go with this VGA to arcade CGA adapter from mikesarcade.com, which might have been a mistake, as you'll see shortly, but the wiring diagram seemed to make sense for what I needed. So I went in on a day the arcade is closed and got to work on this upgrade. Now this is one of the cleanest cabinets we have inside since it's only 3 years old and it's never been exposed to to cigarette smoke like a lot of our 80s cabinets have. Before I took the old board out, the first thing I needed to do was validate that the video was even compatible with the arcade monitor I was using. So I just sat the X16 in a chair and ran some wires, and at first, things didn't look too promising. But eventually I discovered the problem. Okay, so after a little bit, here's what I figured out. So I was going through trying to figure out exactly which of these pins would be the composite sync pin, since it's a little bit non-standard thing for VGA. But one of the things I eventually figured out by almost accident is that this connector has been placed on backwards. So anybody that knows anything about arcade systems, you'll know the first 6 is supposed to be your standard video signal, and then over here is for some alternate sync methods and whatnot. But when you flip this upside down, you'll see that RGB and ground and so forth is actually over here when it should be over here. So I think what I'm going to need to do is desolder this connector and flip it around. And that's exactly what I did. Since these pins were too large for a Hakko desoldering gun, I had to use a desoldering braid and a lot of extra flux to get this connector desoldered, but I eventually got it out. I got it turned around and soldered back in. And after cleaning up the flux, I blow dried it with our little air duster, and there we go. Next, it was time to try it on the actual monitor again, and there we go, it works, and it looks good. At least for the moment. In basic, the screen mode is set to 240p. But when I put in the game cartridge, my game activates interlace mode, and this monitor does not like that one bit. And the funny thing is, it actually looks perfectly fine on camera because it's only picking up one field. I tried different camera settings like 60 FPS, but that didn't seem to help any. But I can show you how it looked using a paint program. So in this example, this would be both fields properly displayed at 480i. And as an example, if your fields are slightly out of horizontal alignment, sometimes you get this comb effect like this. But that's not what I was getting on the arcade monitor. Instead, the fields were misaligned vertically and looked like this. Now the fix wasn't hard, I just had to go into the code and turn off interlace mode and reflash the cartridge over again. But once I was sure the game was working, I pulled out the Amiga board, installed the commander in its place, and you can see my little controller board next to it here. And the reason for the ground block is because in the original design with the Amiga, I was having the buttons essentially activate keys on the keyboard of the Amiga. So they were on a key matrix, which means each individual button had 2 wires coming down to the board. Now, since I have a common ground with all the buttons now, rather than rewire the entire control panel, I just added this ground block to solve that. And now that it's all back together, time for the main test. I'm facepalming here because there's a super obvious problem that somehow I did not anticipate.
I cannot understand how I could have made such a fundamental mistake.
So the problem is the commander requires that you turn it on with the power button. It doesn't just start up on its own when power is applied like a proper arcade machine should. However, the power system is controlled by this small microcontroller, and I asked Kevin if he could make a custom version of that powers on instantly, which he did. And so I'll just replace the chip. And there we go, the new game is up and running, and so now I challenge you guys to come to the arcade in person and leave your mark on the machine by winning a level and putting your name on the scoreboard. Okay, as promised, I said I would show you the Commander X16 second generation board. So this is a prototype. First thing I want to let you know is that we actually hired Stephanie Allaire to design this board for us. So you may know her from projects like the Phoenix, for example. And she makes a lot of other cool products too. So anyway, yeah, so she designed this for us. And this is not the final board. There's a lot of things that are going to change on it. But I want to talk about some of the things that are different. So first of all, let's compare the size. So this is the old board, and this is the new one. And as you can see, it's a little less than half the size of the old board. Plus, the old board was actually 2 boards because I had the daughter board, and this one has everything built onto a single board, which will make it much cheaper to manufacture. So you may be wondering what this hole here is for. That will be for the Wi-Fi module. So basically, what we have here on this expansion card, as you can see, you just have this Wi-Fi section here. So that will simply be an option that you can install here. That way you can get the Wi-Fi option on here. This board also has, and I can't see it very well, but this is the Dream chip. And that is the same chip that is on this little board here on our MIDI card. And we thought that would be cool to put that as a built-in on the board. However, we just found out that chip is being discontinued, so we really don't want to use any discontinued parts, so that will be going away. Likewise, the Yamaha chip and its DAC next to it will also be going away. We're hoping to consolidate that into this FPGA. Now, this FPGA here is currently doing the job that most of this glue logic was doing on the old board. That allows us to do some interesting things. So you may notice this is the CPU, and it is a 65816. Of course, it boots up in 8-bit mode, so it's totally compatible with like 99% of the software for the old Commander. But when it's running in 8-bit mode, it's going to use the same memory banking scheme that the original board used. But what makes this interesting is because we're doing this in an FPGA, it gives us a little bit more flexibility. So when the chip goes into 16-bit mode, we should be able to have access to a full 16 megabytes of RAM in 16-bit mode, and it will be fully addressable with a 24-bit address bus. So it's going to be like a true 16-bit system when it's in 16-bit mode. Anyway, some other changes that are going to happen is this ATX power connector will be going away. We'll eventually be doing either just a standard barrel jack or maybe like a USB or something for power. And the S-Video and Composite are likely going to be going away too. There'll still be an option, like we're going to have some kind of like maybe a pin header or something on the board where you could put like a daughter board or something to get those features, but I think by default they're not going to be there. However, you may notice that HDMI is now an option, and so that's something a lot of people have been asking for. Of course, I really can't call it HDMI. It's HDMI compatible, let's put it that way. So we have a standard cartridge port right in the middle, because this will be oriented sort of like a game console. And yeah, so let's plug it up and let's have a look.
So as you can see, it boots to BASIC, and it's already at a level of near perfect compatibility with the original system. In fact, I'll start up one of the newest game ports, which is Super Mario Bros. 3. I'll go ahead and tell you now, not to get your hopes up for buying this anytime real soon. I mean, we still need to go through several more design iterations, and then we need to develop a case for it. And then we still have to figure out how to get the parts for it, considering the new tariff situation. So I wouldn't be surprised if this isn't a year away from production, but I just want to let you see that progress is being made. Also, I can show you the cartridge port working with the Pesky Robots cartridge I was showing off earlier. And while everything looks to be running fine, there's one serious problem to be fixed, which is the fact the cartridge port is backwards. As you can see, we'd rather the cartridge label be facing the user. Okay, and just a few final announcements. So even though the second generation board won't be available for quite some time, we still do have some stock on the first generation boards if you're interested in those. Speaking of stock, so I know I said I was getting rid of most of my merchandise, but I do still sell like light copies of most all of the versions, which is basically just a manual and a floppy disk. So those are still available if you're interested, but I also have some boxed versions of the MS-DOS version that still remain, and I have some special boxed versions of the Super Nintendo version, but I'm actually not selling these on my website. I only had 100 of these made, and so I've been selling them at the conventions I go to. And speaking of conventions, in a little less than a week, I will be at the Southeast Game Exchange in Greenville, South Carolina, so I hope to see you there. But anyway, that's it for this episode. The next episode, hopefully, if I get it finished, will be on the long-awaited documentary for the Texas Instruments TI-99 4A. So stay tuned for that. And as always, thanks for watching.